All right, welcome to session number 4 for the day. Today's session is with Dr. Konstantina Gramatova. Dr. Konstantina, in few words, she's the senior product architect at Bosch.io, nearly 10 years of experience with embedded software development, device attestation, and communication protocols, integrations, and new edge computing trends like cloud native technology adoption, local compute and data processing, AI enablement, collaboration in different university research projects that targeted AI context aware and multi-agent systems robotics. She received her PhD as a result of the collaboration back in the early years. She's an unsettling OSS campaigner by heart. The result is Eclipse Kanto, one of the latest Eclipse-related projects, Eclipse IoT projects, which we have launched earlier this year. She's been with the project before they even knew its name, when it was just a bunchy, sketchy boxes on a whiteboard behind closed doors, hoping and wishing one day it would be an open. And here we are today. So the mic is yours, Dr. Konstantina, and good luck.
Thank you, Hassan. So glad to have you all here. And so what are we going to talk about today? So as Hassan already mentioned, actually, Kanto that we see here now was quite a bit of adventure that has a lot of history behind. And what we wanted to share with you today is actually a little bit more regarding what we have been through, what we have learned along the way, and how we have captured all of this into what we provided and contributed to Eclipse IoT, and that's our project Eclipse Kanto. So to start with something that's actually very familiar, and maybe if you have seen other our presentations, you have seen this slide as well. But this is just a starting point to see where we are today. The digital transformation is hard, and there are a lot of challenges that are opposed to each of the domains that you see in all around the devices. And you can see that the intelligence is moving to the device, which of course requires local computations. We are seeing how cloud technologies are moving to the edge in order to enable all of that local computation and facilitation. And of course, with having so many different various devices and to cover all of that diversity, we are seeing how hardware is actually moving more and more to software, which means more and more abstractions are done, more and more portability is trying to be achieved in order to have all of that ecosystem connected and all the devices communicating, sharing data, and aggregating the knowledge they're actually producing. That, of course, has its effect on all of the domains. It's not only about mobility or goods. You can see that also in connected buildings as well as manufacturing, because each time you have a lot of devices, each time you want to do that connected ecosystem of devices, distributed ecosystem of devices, every time you face this case, then you will most probably meet all of these challenges when you try to implement a solution to cover it. But these are not problems that have happened today. This is a process that has built up along the years, because, for example, 20 years back, there was not such a variety of devices. No one actually thought about that today. We will have so many connected devices, so many wireless technologies, and so many Gs already, 4, 5, 6, and so on. So if we take a look, what is your best teacher? So here on this diagram, you can see a lot of information. I will walk you through it just to have an idea why I have actually titled this one "Experience is Your Best Teacher." Usually, when you're facing some kind of a case, you want to do something with it, then it's best to get your hands dirty with it, which means that sometimes only going through specifications, going through ideas, what some devices might do or might not do, that would not do you the 100% results you're going for and you would wish to know when you started these projects. What you're seeing here is actually the history of what was there before Kanto came up, what was the team involved, and how many years actually the team was involved in getting this experience, in gaining this knowledge, and in the end transferring it and consolidating it in the Eclipse Kanto project that is now available in the open source. Actually, the history dates way back, and in the core of this history was OSGI. For those who are not familiar, this is a very distributed, very flexible framework that allows you runtime to configure, to start components. It's service-based and so on. Actually, it provides you a lot of flexibility runtime. Which of course benefits you when you have a dynamic system where you, for example, have a lot of devices, have a lot of services, have a lot of changing configurations and so on and so forth. And that's a great solution. You can start for example, in 2000, when actually the first release of the specification was done, and back in the days when the first MBS product of the system of the firm process, where actually the team started from, was released. After that, there were different iterations. As you can see later on in 2010, actually MQTT 3.1 actually became public. Part of the team are contributors to this protocol as well. As being there and making history, which is really a nice thing if you're there and you can see everything happening. And in 2019, then we released another version of the product. It was rebranded as becoming part of the Bosch family. Then we introduced this product with a lot of new and improved features. Actually, this was the result of a natural transition. So if you see the trend in the green in the lower part, the edge computing concept actually evolved along the way. And it's no secret why, for example, you can see MQTT going public and available in 2010. You can see cloudlets, fog computing, and so on and so forth, growing and starting to emerge as concepts, because over these years, actually, a lot of protocols, a lot of devices started emerging, like, for example, wireless protocols like Zigbee and Z-Wave. This is actually the reason why all of these concepts and why all of these technologies started emerging, to be able to cope with that complexity right there at the edge. Actually, cloud and edge computing emerged as a term, actually not really recently. As you can see, the history dates a long back. But now, as having so many connected devices, so many IP-enabled devices, we have the ability to achieve something more, to gain all the lessons that we have learned along the way, along all of these years, connecting devices, getting to know what the real environment looks like, getting to know battery-powered devices, wired protocols, and so on and so forth, and all of the pitfalls you can jump into along the way, learning how to manage and how to do that as well. So, as experience is our best teacher, the question is what we have learned after all of these years. Well, what we have learned is that if you want to achieve all the pluses of being there, being closer to where the data is produced, allowing all that operations to happen right there on your edge device, then you need to ensure low latency. You need to reduce the complexity and cost, because the more traffic you gain between the edge devices and the cloud, then the more you hit the costs, and the more, of course, you make vulnerable your solution to continue it. And of course, this is how you improve efficiency and resilience as well, because the more independent the device can operate on its own, then the better it gets when it has to cope with complex use cases, with local processing, and with event-driven notifications or communication with the cloud when it is needed, not just flushing everything along the way and with remote communication. And actually, to achieve that, there are a couple of key aspects that you need to have in mind to achieve all of that when building up an edge solution. First things first, you have to make sure that you have 100% 24/7 availability and reliability of your product. If you cannot achieve that, then you're in big trouble because data gets lost, because you can get corrupted while you have not been operating, and so on and so forth. So this is painfully aware, I guess, for many of the people that are here with us today. Remote management and updates, that's out of the question, but what's more important here is to do that in a unified manner, which means that if you have to cope with hundreds and thousands of different kinds of devices, the only way you can scale that is to provide a unified API to do that. If you do not manage to do that, again, you're not resolving the actual complexity you're there for to resolve. So this is also a very important thing. And local computation and apps. So as already mentioned, so lessons learned. When we talk about OSGI, that's a great framework, really flexible, really suited for embedded. But when you come to the point that you have to do something, a custom extension or something like that, then maybe the developer experience will not be that great, because at this point you're facing a whole lot of specifications to run through before you can even write a single plugin or extension at that point, which is great for people who are really aware of that specification, but can be a cumbersome job for someone who, for example, has already been learning Python or Node.js or something like that, and just has a simple app that wants to run on that edge device. And also to enable analytics and machine learning, which the data is there for. You have to be able to scale these applications to make sure that you have an environment for them that will keep their life cycle up and running. And of course, you have to ensure open APIs for the remote applications, which would be running somewhere remotely. In the end, it's not about, you cannot encapsulate everything fully at the edge. At some point, you would have to transfer some data somewhere in the cloud to do a heavy processing that you cannot do in such a distributed environment. But then you have to make sure that your APIs for that remote communication are open enough and the applications can integrate easily, in the best case, following some open standards already available in use. And of course, to be able to achieve all of that, to have this local computation and unified APIs, then you for sure need device abstraction and digital twin. This is your key to unlocking actually the potential of resolving the complexity. If you do not have this abstraction, if you're going device by device, if you're going case by case, then again, you're not resolving the complexity. With the digital twin, you enhance your system to be able to be state-driven, to aggregate the state, not messages, not actions, and so on and so forth. And you enhance the synchronization between the edge device and the cloud when this information is needed to be synchronized, and you can get all of the history needed for the different changes that has come up for this state. So having all of that learned, then we started asking ourselves, okay, what we can do, because the solution that we already have, and we still have actually, is a great solution, but we need to somehow build the infrastructure around it to ensure all of the key points that we already mentioned that are there, that we know actually how we can achieve all of that easily, which is the first pillar of what we try to do, and of course how we can do that in an integrated manner so that it's again easy for adding additional applications, adding different services, extensions, and so on, which is a problem that we have met past in years, and now we decided to resolve it in a very open manner so that we can do that. What you see here on the left hand side, 2019, we started actually, this is one of the currently not really a sketch, but let's say the architecture, how it looks like in the core. Back then it was called the Bosch IoT Edge Agent, and it's kind of a simple idea of adopting several concepts, and all of the decisions that we take at that time were driven by three main ideas. We always go for public specifications and de facto standards, because this is the only way you can ensure that your system is flexible, pluggable, portable, extendable, and so on. If you go for customizations, if you go for closed protocols and so on, then again you have a problem. For sure, you being on the device, you have to ensure that the solution that is running there is lightweight. And back in the days when we had different languages on the table, and it was kind of a various language environment when we started, because, for example, the cloud connectivity was first written in C, but when you come into the point that you have to tackle with encryption, with communication, encrypted communication, and so on, then in the end, it turned out that the best way would be to unify all the implementations and go for Go. So having this Go, in the end, the third most important pillar that we're considering back in the day was keeping in mind that we are going open source, and open source language in the core of this project is very important in that sense as well. Because it gives you the environment, it opens you the door to contribute, to help evolve, and of course to help yourself by evolving the ecosystem around it as well. And this is how in 2020, actually October, we released the first version of the Bosch IoT Edge agent. Back then it was behind closed doors, but actually the idea that we're providing the essential AIoT enablement for your edge device, it was already clear that all the capabilities of that product must be available for the open source society. Because this is not something you would expect to be closed doors. This is something that its places in the open source. And we strongly believe that this is actually the shortest way to reach out to the most devices, to reach out to most people and communities. And that's the way such essentials that need to be closer to the device will evolve. And that's the way how these features should continue evolving in the future. And this is how, actually, if we have to sum up what we learned even for that one year and a half after the first release of this product, and trying it on real use cases, then what we sum up and can gain as a knowledge and the four more important aspects and benefits is actually adapting cloud native technology is very important, but also you have to ensure a cloud neutral edge device. So, which means that you cannot just get what's out there already running. You need to adapt it in a way that works your edge use case, where you have different constraints, requirements for the resources, different environments, different custom OSs, and so on and so forth. So you have to be very careful when choosing what software to include and to run on the device, and this is why we are focusing on cherry picking, not on getting and using as is. The second most important thing is actually making a secure runtime and manageable runtime, which containerization comes into play. This is a very known approach, let's call it this way. It's always about isolation when you want to secure that one process will not just kill your device at some point. And of course, connected well with the different protocols that we integrated in the years and different ways we managed to handle them and to provide connectivity to the cloud. The key learning is that you have to have the minimal time for prototyping and for using any protocol to your device, but that should happen through a single connection point, which ensures that only one person or piece of software, let's call it this way, is responsible for handling all the complexity with remote connectivity, with connectivity loss, and so on and so forth, so that you can have your solution running. Last but not least, flexible. Well, lessons learned again. Flexibility is very important. Being used to such a dynamic environment and getting the benefits of this dynamic environment, we wanted to keep this concept going. And what we aim for here is actually to not force any piece of software to be running on your device that you actually do not need, which means that you can pick and choose from set of building blocks and just add only the building blocks that are of interest of your solution or that work best or that fit best your solution and your hardware as well. And all of that being learned is now actually encompassed in Eclipse Kanto that we will, in a couple of minutes, see in action. So we started small, but the direction was clear, adopting open source and open standards. So that's the way to go if we want to reach out and be able to learn more and collaborate and evolve along the way. We started with Eclipse Hono with a couple of actually Eclipse IoT projects, Eclipse Hono for connectivity, Eclipse Ditto for digital twin. For communication, we use the de facto standard Mosquito and Paco as a library for the different clients. For modeling, we used Eclipse Vorto. And for unified software updates, whether it's about firmware update of an end device, whether it's about a firmware update of the gateway that is in front of this end device, whether it's about only installing some software or containers or whatever, this is our unified approach for any piece you can update on the device or install on the device. And of course, as most of the edge devices today are targeting Linux operating systems, we started going step by step with the parties, getting to know each other as being one of the open source reference images, providing Yocto meta layers to try to integrate with the Yocto ecosystem, and of course, in the future, Ubuntu snaps. What we did for containerization was actually not an easy choice because at that time, the key player, when you say containerization or containers, it was like, okay, that's Docker. Docker was a synonym of container. There were not a lot of solutions, but we looked into what was there at that time. And what we were going for was actually exactly finding the essential core that you would actually need on your device without, for example, building tools and so on and so forth for images, the things you would most probably do in a CI/CD, but would not do on your edge device. So this is how we came up to the Mobi project, and of course going for specifications. OCI was already well adopted, has different even lower level implementations, and this was our choice based on the three pillars to get public specifications, lightweight implementations, and open source. Of course, Podman as an OCI as well, compatible runtime is something that you can plug, and we will provide that in the future as well. And for orchestration, we are looking into Kubernetes APIs, but in terms of APIs and concepts, it's not about running Kubernetes on your edge device, which most probably would not work and give you headaches, but only on APIs and concepts, so you can see, we can adapt and cherry pick and see what would fit best our use case. And this is actually how we came up with the current architecture, with the current building blocks, and I'll just try briefly to go through them. Starting bottom up, as we are on the device, different operating system supports, as already mentioned, Debian packages, Yocto meta layers, Ubuntu snaps, and so on. Container management and orchestration is actually a pluggable layer. As already mentioned, as we want to go to public specifications and lightweight solutions, OCI is not the only one, because if you look into lightweight, for example, XC is another great solution that you decide to use in your end-to-end solution. So this is something as well you can plug underneath the container management and orchestration layer that Eclipse Kanto provides. Software updates and edge management, which includes, for example, files, file uploads, backup and restore, and other integrations that would enhance your management of the device and its state, monitoring, and so on and so forth. Again, using the same Vorto modeling, using the same Ditto approach with features and so on. And the edge applications you can deploy on top, whether that would be as containers or you would implement them natively if you want to run them on the device. And all of that is actually connected on your edge device via the local communication that we rely on Mosquito there. So it's a local MQTT protocol on the northbound side. Sorry. On the northbound side, you can see that's actually where the cloud connectivity happens. And on the southbound side of the cloud connector, there is where the local communication happens. So The cloud connector is actually the key player when it comes to handling all the different connectivity endpoints with remote backends, like for example the Bosch IoT suite, like for example which is powered by actually Honodito and Hogbit, and we are currently integrating cloud to edge Eclipse IoT package so that we can provide you with a fully open source solution if you want to try this one out, but as well as Azure IoT Hub. All of that on the device itself is happening, and the communication is happening based on the device twin provided by Ditto and the communication protocol using Hono to enhance the different acts, let's say telemetry, command and control, and events happening on your device. So the big launch. So February 2022, we made the initial contribution, and March we managed to release our first milestone release with the idea to enable you to try out Eclipse Kanto as easy and as fast as possible. It was a great journey, and since then I'm really happy that I can actually already see so many interested projects in Eclipse Kanto that we're currently going into different storylines, different communications, and looking for synergies. And we are participating actively in different working groups. You can see, for example, like software-defined vehicle, edge native working group, and collaborating with the CVI working group of Cuvisa, which is actually standing behind the VSS and VSC standards for vehicle data modeling and services. So it was a great journey, and in the end, actually, it created the wave and managed to produce so many connections and collaborations into the open. And this is actually, if you look into the picture now, we started small, but this is how the picture looks right now. So if we have to take a short glimpse out of it, so we started with Honodito, Vorto, Hogbit, and so on and so forth. And right now you can see so many projects involvement, so many working groups involvement, different standards and specifications that we are already looking for integrating based on real use cases so that we can prove them. We can see that we can be neighbor for all of these use cases, and collaborating with different organizations like, for example, Collabora, Rexroth, and so on and so forth. So it's a great journey, and in the end, what we are proud of actually today is that we managed to create exactly these synergies in communication and to serve our purpose to be the essential AIoT provider for your edge device that you need to start up and build edge use cases in all of the domains, not a single one. So just a quick brief, what's coming up. So already releasing the milestone 2, what we decided to move on is actually based on this communication and collaboration, we can enhance all the already provided features, and we can enrich them in the future in the next milestone release, and of course continue our interesting collaboration with Collabora regarding the Portis integration out of the box. And be able to provide with even more documentation, because this is an essential part of the user or tryout onboarding with Eclipse Kanto. And if you want to stay in touch, or you have any questions regarding Eclipse Kanto or what it encompasses of, then feel free to reach out to us, whether it's me or Anna Gramatova, which is the other project lead of Eclipse Kanto. So we'll be glad to have you on board. And now, because we have only a couple of minutes until our time's out, let's see Kanto in action. First, briefly, I'll walk you through what you are about to see right now. So we will be using Bosch IoT Suite as a backend because it has a nice UI, but in the end, what we will be doing is actually show you how we integrated Eclipse Kanto with Eclipse Kuxa for the automotive use cases. So we'll have Eclipse Kanto installed on a Raspberry Pi. As you can see, the container management is communicating based on the digital twin that we have in the Bosch IoT Suite and locally. And as a first step, we will install one container, which is actually Kuxa Val. This container, which is available in the project, you can find even how-tos in the Kuxa project GitHub repositories. And after that, we will install one custom Python application that we're soon about to contribute to the project, and we will be there to try out as well, which would actually receive VSS data via VISS protocol, and then based on Dito and Kono, it registers a new feature in the digital twin that we will see that actually makes the data available in the cloud. And the third container that we're about to install is actually one Kuxa GPS feeder. And this is, again, a project you can find in the Kuxa repositories. What it essentially does, it receives, I'll use just one test phone here. It receives GPS data from a car. In our case, it will be just a smartphone car. It transfers it to the Kuxa Vault server, where, again, via the Kanto client, which is making the needed transformations, then the data is sent to the digital twin in the cloud, and then it is visible in the cloud as well. So without many talking, much talking, more talking, let's see what we have here. So this is my Raspberry Pi. As you can see here, it's an ARM64, and this is my local machine here. That's a Debian testing board. Okay, so going for actually to the documentation, I'll use it as a hint, and I will install Eclipse Kanto using the first milestone release. I just have to fix it for ARM64. Okay, and while Eclipse Kanto is installing, then I have a Bosch IoT subscription, and I will provision a new device so that we can use for our cases. So we will start from scratch. We will make it a gateway device because we have virtual things that encompass the virtual capabilities, like, for example, container management, and this is why I'm enabling automatic provisioning of edge devices. Let's call this, why not, IoT, very secret password. And this is all I need to do to provision my new device. Okay, I will save the response for now. And go back to my things. Now, if we write IoT, ooh, that was not a very only name. Okay. Okay, so now our device has never been connected. It's a gateway device, but we will leave it for now. And we can see now that actually our installation has finished. If we go back to our installation guide, let's quickly check if everything has gone well. Okay, everything seems green, which is good. And now I will do a small configuration but actually let's first make the device screen. Okay, so we will copy the name, the provisioning JSON file that we just created for our device. This provisioning JSON actually contains all the authentication, authorization, and connectivity endpoints information, which in this case Eclipse Kanto uses to connect. Now, if we go back to our things, the only thing I need to do now is actually copy the provisioning file to etc suite connector, which is the directory which is dynamically monitored by Eclipse Kanto. And at the moment, the suite connector gets that information. It takes a little bit of time, but you can see that now our device is connected. And one more virtual thing, which in our case is edge containers, which encompasses all the container management capabilities, is here. Okay, so quickly, looking into the features right now, we can see the different edge management capabilities and software updates. But now let's see the features of the container management as well. You can see container factory, software updates. All of that enables your remote management for your device over the air. So let's now start installing the containers, which I will do over IoT rollouts console. Okay, doesn't need to roll that, but anyway. So first we will install the Kuxaval server. This is just but no. First, actually, we will add one insecure registry because I have all the images in a local registry where you can see that I have different images already here. So let's configure the container management to have this image registry as an insecure one. Just plain. Okay, to do that, we need a simple configuration, which is actually very similar to something you would see in Docker. And this is the IP of my registry. Okay. Okay, now let's restart the service. Let's see the status again. Okay, everything is up and running. And now, if we see what we have on our device, we have no containers on our device. Now, let's quickly install the 3 containers. So first, Kuxaval. We'll install this one. It takes a couple of seconds until actually the call is made to the device. So as you can see, I have made different tries before running this video. So yeah, the images are pre-cached, but keep in mind that if you do that for the first time, it might take a little bit longer because the runtime would need to download all the image from your repository and start using it. After that, things get faster because you have the image already installed and cached on your device. Okay, quickly being impatient. This one is still installing. We'll give it a little bit more time. And maybe in that time, we can wake up our device. It takes a little bit more than expected. Let's see what's happening here. Fine. Well, as they say, second time is on the luck. We'll give it a second try. Like that. Okay, so rollouts is not our friend today, as it seems. good thing is that we always have a console and we can do that by hand. Okay, let me just open my quick shot. So Kuxavao, let's have this installed and running. Okay, we have it running. We'll quickly get this one. Now we will install the Eclipse Kanto container. If you want, you can watch the video later to see the actual. And now we'll create, we'll start the GPS feeder application. Okay, cool. Okay, so now let's see what we have done here. And now let's start the containers one by one. So we're starting Kuxavao. And now let's check out our digital twin. Hopefully, this one is fine by now. Okay, let's list. It's running. And now we'll start the Eclipse Kanto container, which actually, when it gets running, it will create a new feature in our device, which is called VSS. And here you can see longitude, speed, and so on and so forth, which is actually the VSS data. And now the last one, let's start the GPS feeder. So I can give you guys time for questions and answers. And hopefully, if this one starts as well, let's make a list again. Okay, this one says to be running. Okay, so what interesting is here, now I'll use my phone where I have GPSD running on that Android phone. This is a very actually handy program. It takes a little bit time until it feeds the GPS data, but oh, cool. So it initializes with zeros at the start. It takes a couple of seconds to see what's happening. I'll keep moving my phone right now for it to get a little bit of data. But I think with that, the demo is near to its end, and I'll be actually glad to take up any questions you have if you're interested in some of the topics or features until we actually manage to produce some meaningful GPS data moving around with the phone, taking a couple of minutes and seconds.
Sure. Thank you so much, Dr. Tina. Amazing, like always, amazing presentation, and thanks for the demo. I must admit that Eclipse Kanto is one of those projects that I personally witnessed the birth from the beginning, and happy to collaborate with the rest of the team at Bosch to really amplify the great work that you guys are doing. I think I have one question from Alexander, and I think what he's meaning by his question is, what's the smallest runtime footprint for a minimal Kanto installation?
Yeah, well, that's a really interesting question. For me, there's not the smallest, let's call it this way. For me, there's always room to improve and always new features to optimize will exist and emerge. But let's say that we have done some experimentations. It's about the size of on disk of Kanto can be lowered down to 20 couple of megabytes, and actually the RAM that is needed is very, very low, given that most of the processes, and if you make a minimal installation, most of the processes are mostly sleeping, so they would not eat up your memory. But that are the figures I remember by heart now. If you want, you can drop me a mail and I can give you the exact numbers that we made this measurement back then. But this is what I do recall at the point where we did some experimentations and stripping and making a minimal installation. Of course, it all depends on what are the components you decide to put on your device. But this 20 something was actually the cloud connectivity alongside the container management layer on top as well. Hope that answers your question. Feel free to drop me a mail for the exact numbers.
Okay, sounds good. One more comment. So Eclipse Kanto, hopefully we're looking forward to see Eclipse Kanto and EclipseCon. And talking about EclipseCon this year, EclipseCon is planned to be an in-person event. So the early bird submission is June 1st for the proposals. So in the next few weeks, you're going to be see the program panned out for the conference. Be sure to keep your eyes on the IoT and Edge day track. We will be having one day specially designed for IoT and Edge and Sparkplug related talks. And exciting announcements are also planned at EclipseCon. One more thing, the Eclipse Foundation this year will be part of Bosch Connected World BCW at November as well. And we look forward to having a great booth with the rest of the partners, Bosch, Red Hat, HiveMQ, and others who will be major sponsors of the booth this year. So stay tuned for BCW this year. Very, very exciting project. I don't see any more questions in the chat box, but in all cases, if you do have any questions, you can always reach out to Tina and rest of the Kanto team. One more time, thank you so much, Tina, for the great presentation. Any final words?
Well, thank you everyone for joining. I will be really happy if you find some piece or aspect interesting of Eclipse Kanto. My best hope would be if you find that something interesting, just ping, we'll discuss. I'm always open for discussion and really curious about other cases, about different thoughts and views. So just feel free to reach out. That will be the best case we can involve. So thank you.
Lovely.
That's on my
Thank you
side.
so much.